action. Maybe. Pause. Alright, the first clip we saw is a rotational speed fail, or a center of gravity fail. What happened was the gymnast had a little too much rotational force, which caused him to start to do an extra flip. When he should have tried to stop and land on his feet. A solution for this would be to put less rotational force into his initial flipping, or to stretch his positions a little more to slow down his rotations so he can catch his balance. He could have also tucked his body in tighter to get more rotations to try and complete another full flip and land on his feet. His technique is what was flawed.
Boom.
Alright, what happened in that video was it was a momentum fail. The fail is specifically an elastic head-on collision between the two people. The girl is sent flying the opposite direction and the boy barely moves. They did not have equal momentum, which would have caused them to both take off in the opposite directions. The girl had less momentum, and to fix this, she would have had to move faster towards the boy, and he may have to slow down for the equilibrium to be achieved. She also has a lesser mass than the boy, which is why he can stand his ground better when they collide. In order for equal forces in opposite directions to occur, she needs to run towards him harder and faster.
Action.
Alright, what happened in this video is a friction fail between the wheels of the vehicle and the road. Ice is causing the friction to be very little, even when the car is going very slowly trying to stop. When she applies her brakes, the wheels stop turning, but the car continues to move. In order to fix this problem, there are three options I can think of. You could get bigger tires or add weight to the car, which would add more friction. The next is to get tires with better treading and work like spikes on cleats, like when you walk in cleats on the snow and it keeps your traction. And the last option would be to wait for the ice to melt, or lay something like salt on the ice. You need to have contact with the asphalt in order for friction to happen.
Action. Duh.
Alright, I use this clip as an example of a gravity fail. We all know that what goes up must come down. In this case, he tried to ride his bike up a steep hill, but didn't have enough upward or forward velocity or momentum to finish the climb. He tried to stop on the side of the slope, and the force of gravity from the earth pulled the bike and the man down the hill. A solution to this fail would be for the man to build up more speed. If he goes fast enough, he will have enough momentum to make it up and over the hill without falling back down.
Action.
What happened in this video is the guy was slowly walking across a frozen pond or lake. As he begins walking on the ice, the equal and opposite force between his body and the ice, his body and mass is pushing down on the ice, and the ice is pushing up on him. As it continues his path across the ice, it causes little cracks to form, and the fail occurs when he steps too hard in his path and the ice can't push back with enough force to hold him above the water. This causes his body to force its way through the ice, and he gets really cold really fast. There are a few things he can do to try and prevent this fail. The first one would be to try and step very, very lightly, which will put less force on the ice. Another solution would be to maybe make himself lighter or wait for the ice to freeze harder. This will give the ice more time to become compact, and he'll be able to walk across it easier without falling through.
Action. Just like Sam tried to do a flat back.
Alright, what happened in this video is it shows a man attempting to do a front flip off of a ladder. The fail occurs when he ends up diving head first into the ground because of the lack of rotation. Physics tells us that there are a few ways to fix this problem. The first way is the major reason why he fails. To increase your rotation, you need to tuck your body more. He leaves his body in an outstretched position, which only allows for a quarter of a flip. The tighter he brings his body in, the more complete the flip will be, and the more speed he'll gain to do his rotation. He could also have the ladder he jumps from be a little bit taller. This will give him more time to do the same technique that he used. He would need a ladder at least twice as tall in order to have enough time to rotate that slow.
Action. Early. What the heck?
Alright, in this video, the boy failed because he tried riding a skateboard with stilts. The reason he topples over is not because his center of gravity was raised, but because it is extended beyond the center of gravity. If you look closely in slow motion, you see him go down the ramp. His body leans towards the camera and off the support base. When this happens, he fell off and looked like a moron. A possible solution for this would be for him to try and keep his balance a little bit better by keeping his center of gravity inside the support base. He may also have more luck using a bigger and wider skateboard. This will make the support base a lot bigger and give him more area to lean. The inverse of this would also work. If you wanted to shorten the stilts, it would lower his center of gravity, making it easier to stay in the support base.
Action.
Alright, what happened in that last video is the classic person trying to board a light watercraft. The reason this guy falls in the water and fails when trying to get on the kickboard is because he and the board act in equal and opposite ways. This means that all his force acting on the board is coming back to him from the board as well. Since the board is on the surface of water, there is no friction to hold the board steady. This is why he fails and lands in the water. The board uses the same amount of force against the man and moves out from underneath him. Some possible solutions to this problem are trying to get on the board in the sand first and then entering the water, where the sand will cause friction with the board and mostly keep it from moving when trying to get on it. Another solution would be to have someone hold it still in the water while you get on it. And lastly, I think he probably shouldn't have had his buddy push the board and give it a head start in the water. That made it harder for him to board it without falling.
Action.
Alright, in this video you see a rather large man try to dunk by jumping off of a trampoline. The reason he fails and body plants on the mat is because he stopped his momentum. He was running, gaining speed, and then before he mounted the trampoline, he slowed and stopped. This got rid of most of his momentum and reduced the distance he could fly to reach the rim. The easiest way to fix this, other than the man losing weight, allowing for easy progression into the stunt, is to decrease the distance from the trampoline to the rim. If they took away several feet from the distance between the dismount and the basket, he'd be able to jump the distance a lot easier. Another way to fix this is for him to not stop his forward progression. This will give him a fluid mount and dismount into the dunk.
Action.
Alright, what went wrong in this video was because the man on the merry-go-round is trying to hold his body with just his hands. The merry-go-round picks up rotational speed, and as it does, the man has a linear and tangential speed trying to force him in one direction off of the merry-go-round. And once he goes too fast to hold on, he lets go, and since only half of his body has a back support, which is the bar that he's leaning against, and he isn't strapped down in any way, he is sent flying off. The few ways to fix this is for him to maybe sit on the floor of the merry-go-round. That way his whole body has a back stopper to hold him in. Another way would be to not just use his hands to hold on. He needs to somehow be strapped in on the merry-go-round, that way he can't fly off so easily. He needs some kind of centripetal force holding him that is stronger than the centrifugal force pulling him out.